Hello guys, so in this video we're going to go over how to do exponential integration, but this time we're going to do exponential integration without when your base does not have Euler's number. So slightly different, but I think it's still very straightforward. So without further ado, the first step is to realize what is your base. That's the first step. So what is our base? Our base is A. So our base is equal to A. And our exponent is equal to U, as right here stated. A raised to the U power. And if A does not equal Euler's number, which they do mean the same thing, then apply this method of integration. Then apply in this method of integration. Integrate using this formula. So the first things we're going to do is we're going to recognize that our A is not equal to E. Our A is equal to 3, and our U is equal to just X. So that's the first thing we're going to do. So identify A and U. So identify A and U. So our A is equal to our base. So our base is 3. And our U is equal to our exponent. And our exponent is just X. So now, the next step would be to integrate using formulas. So we're going to go ahead and integrate. So we know that the integral of A raised to the U times du is equal to AU times divided by the natural log of A plus C. So in this case, the integral of 3 raised to the x times dx is equal to A raised to the U. So 3 is our A raised to the U, which is x, divided by the natural log of A, and our A is 3. So divided by the natural log of 3 plus C. And that's how you take an exponential derivative without giving Euler's number. So the idea is, the hardest part is to realize what your base is. So your base, check for this number. And if it equals E, then you apply exponential integration. But if it does not equal E, then you applied exponential integration when you don't have Euler's number. And then afterwards, identify your A and U. Identify A and U, and from there you integrate and you plug into this formula. And that's how you apply exponential integration when you're not given Euler's number. Thank you for watching. I hope this was helpful. Hello guys, so in this video we're going to go over how to do exponential integration when you're not given Euler's number. So when you're not given Euler's number, you actually have to apply a different method of integration versus when your base is Euler's number. So it's very similar, but it's a little different. So you do need to be familiar with the fact that not every base of exponential integration is going to have Euler's number. And this one has 2, so it's clearly not Euler's number. So what we're going to go ahead and do is we need to first be able to recognize our base. And we need to recognize that our base does not equal Euler's number. So our A is equal to our base. And our U is equal to our exponent. And where the heck am I getting this from? I'm getting this from right here. A raised to the U is the way our function is given to us as 2 raised to the 5x. But our base does not equal E. So if your A does not equal Euler's number, then apply this method. So in this case, recognize that your A does not equal E. Recognize that it's not equal to E, so in that case, you do apply a different method for integration. So in this case, the next step is to identify A and U. So A and U is not as straightforward as it may seem. Reason being is because we have 2 raised to the 5x. So keep in mind that we do have a constant. So our A is whatever our constant is, because we want our U to be equal to just x. So our U is equal to x, but our A is actually equal to 2 raised to the 5x, because we want to simplify this, because at the end of the day, this is a constant. And 2 raised to the 5 is simply equal to 32. So that's our A. And our U is simply x. So the integral that we're actually trying to solve for, because the next step would be to integrate, is 32 raised to the x times dx. A raised to the U times du. Same thing, right? 32 raised to the x. So now, without further ado, now that we've identified our A to be 32 and our U to be x, we can go ahead and plug it into this formula. So the integral of A raised to the U is equal to A to the U. So 32 raised to the x divided by the natural log of A. So the natural log of 32. Plus C. And this is an acceptable final answer. You could apply natural log and exponent properties to simplify this a step further, but for the purposes of this video is showing you how to apply exponential integration. It's not showing you how to simplify using algebra. And you should receive full credit if you do submit an answer like this. But the key step is right here, this one, because this will get people. Recognize that your base is not all, it is not E, but keep in mind that 2 raised to the 5 itself is a constant, and your U should always be x. So I'm going to just leave that as a note. So note that whenever you're doing these types of integrations, your U should always be x. So if you keep that as a friendly reminder, it'll also remind you that your A, if it's not raised to the power of x, if it's raised to the power of 2x, 3x, that itself is part of the constant of A. It's part of the base, and you have to evaluate it first before you can identify it as your variable A. And once you identify it, right here it's just a matter of plugging in. 32 raised to the x times dx is equal to a to the u, a to the u, so 32 to the x, divided by the natural log of a, and the natural log of 32 plus c. And that's it for this video. Thank you for watching. I hope that was helpful.